Okay, so the Awesome USA Part 2. Here, we are going to install the LED resistors along the outside. I have not installed my resistors here. These are for practice. Everywhere there's a blank, we're going to focus on the ones with a letter. Okay. R for red. W for white, and B for blue. Now, we are proceeding on to step 7. It's very important at this point that you pay attention to what components you place where. Each one of these resistors has a different color code, different value. Here we have a 330. It starts with an orange, 330 ohm. Here we have a 2 kilo ohm, starts with a red. Here we have a 1 kilo ohm, starts with a brown. So, if we look carefully at these, I've laid these out, and you'll notice that I have my red LEDs. I've removed these from the package. This package here, I put the ones I'm not using back. I have my white LEDs, and I have my blue LEDs. I have not removed these from the package because there is no way to tell the difference in these LEDs once they are removed from the package unless you apply electricity and see what color they light up. The only labeling are these dots. So I'm taking one LED out at a time. I have a little notch. I've tore open the foil bag, and I'm removing one at a time to solder on my board. All right. So I will apply each one of these with the tolerance band to the right, just like you read a book. So let's take a closer look at what we've done. I started per the instructions right above the W. The U. And then I work my way to the right. So per the instructions, I've started here and I'm going right, and I'm going to follow myself all the way around the USA. Do not proceed to the lettering on the inside. That is another step. I repeat, do not proceed to the lettering inside. That is another step. We're going to go all along the outside. You should have already installed your practice resistors without marks everywhere. And we're going to proceed along the outside with our colored LEDs. So I have already installed these. And I'm going to put the video right here with a nice close-up so we can actually look at them. Now, once we've soldered those LEDs and resistors in there, it's time to test per the instructions. That would be step 8. So we are going to plug up our USB cable that was provided to us. And I'm going to plug it into the port and verify that all 3 LEDs are lit, starting with red, white, and blue. I turn this on by flipping my switch that I soldered in part 1 onto the surface board. Notice it is a 3-position switch. The middle position is actually off. Tells it to power off the USB connector, and the other position would tell it to power off the supplied battery connector. So now that all of my LEDs are working. Now, what do I do if some of my LEDs are not working? Well, let's look at that. For step 8, if all 3 in a sequence are not lit, look for a bridge across one of the LEDs. That means your solder run between 2 points. Troubleshooting step 2, make sure that the switch is soldered well. the USB connector is soldered on well. Step 8, make sure the computer's on. We're probably not going to be plugging ours into a computer. If only one LED is not lit because they are in a sequence, make sure you do not install the LED backwards. The LEDs install the same way they have in the previous exercise. The rounded side of the silk screen is the positive and is the longer lead. So my longer lead would go to the outside. My longer lead to the outside, with the short side being on the flat side being the negative. So make sure they are installed correctly. Take your time, do this one at a time. You can install 3 resistors, power the circuit on, and make sure that each one works as you work through this circuit. That's what you so choose to do. So here we have our resistors. What about bridging? What if we bridged our solder? Because the purpose of this project is they've actually put the solder joints extremely close together. And let's look, because I accidentally bridged one, so we're going to look at how to fix that. So we're going to come in over here. And look at this bridge. Do you see how close they purposely put these solder connectors? And you'll see that this one here looks to be touching across here. You also would want to pay attention that if you accidentally bridged across your LED, that would be a short. Same thing applies as before, that when we test these, if we don't immediately flip the power on and see LEDs, we're going to turn it immediately off, because more than likely we've got a short and we're going to burn up something. So when we're doing our testing, if we don't see LEDs come on, immediately turn it back off. If I don't see all of the LEDs come on, immediately turn it back off. Shoot the problem without burning something up. And so I've bridged this with one of my practice resistors that I have not installed, and I'll see that that's been bridged. Now you could use the desoldering tool, the solder sucker, if you wanted to. I find for my purposes the desoldering wick works better at removing some of these overflows. There's no really control over the solder sucker. You release the plunger and it just sucks up all the solder, and then you apply more and hope it's right. A lot of times with a desoldering wick, you are able just to remove the solder. I'm going to rotate my board. I'm going to unplug my USB port, and I'm going to come over here and see if I can't remove some of this solder that's bridging this solder connection right here. I have my wick ready. Tip is clean because the whole point is to get solder off. Let's look at my connection that I bridged right here. Pull this up in the center of the screen, and we'll see that this is my bridge connection right here. I need to remove this solder from this empty pad. Typically there'd be another resistor there. So what I can do is, the best way is to lay your desoldering braid across it, put your soldering iron at an angle so you have a lot of surface area, and simply apply some heat. Now, notice I don't want to suck up all of my solder. I simply want to get it out in between on this one side. So I'm going to kind of go over here. I'm going to wiggle it around a little bit, and I see it liquefy. And I may have removed a tad bit too much solder, but it still is bonded. You can see the solder. I'm going to inspect that very closely to make sure that I do have enough solder on there for a good bond. It might even be a little bit of a cold joint. Once I've removed the excess solder, I'll clean my tip. And I'll apply just a little bit more heat to try to get some of it to run down. See, I didn't even have to apply any more solder, just a little bit more heat. And I got that to run down a little bit. And now I've cleaned off in between there. So let's look at that. Yes, I'm not touching. Looks like I've applied too much heat to this trace by accident. Hopefully that didn't burn my trace, otherwise I'll be jumping that board. Or that might have been a defect. That looked a little odd. So maybe I want to clean this off so I can see. I'm going to take my time and go at a measured pace. It's easier to fix it now than it is to worry about it later. So I'm going to come clean this board, make sure that that did not burn anything. Looks like it came clean, so no damage to the board. Using my isopropyl alcohol and a Q-tip. And that appears to be a good joint. Now, the LEDs, what if I run an LED solder together? Well, let's look at that, because that's going to happen. Same thing applies. I'm purposely going to run too much solder between that. Simply going to pick one and cause it to solder across. Purposely going to put too much solder across it. There we go. I've bridged that. That is a short. That will prevent everything from working on that circuit. So let's take another look at that. I'm going to rotate my Awesome USA project around, get a little bit closer. And I have soldered that LED together. It's way too much solder. Like I said, you can use your solder sucker to try to remove it. I like my desoldering braid because I can lay it between there and usually I can get just enough solder off of it that I don't have to resolder anything. And so I'm going to lay my braid across here. I'm going to apply some heat. Wiggle, wiggle, wiggle. Move it around just a little bit. Did I get too much? Apply some more. If you get too much heat on this board, what you're going to end up with is a bad LED. Now my LEDs have been installed so close to the board that I cannot put a heat sink on them. So you're just going to have to watch it. If you try a couple of times and you're not having any luck, you need to let the board cool off and come back to it. So, very quickly go in there and apply some heat. Don't continually keep applying heat to that portion of the board, or you will damage the component you're trying to fix and end up having to remove the whole thing anyway. So watch how much heat you apply to this board. And so now I've fixed this bridge solder gap right here. All right, we will continue on with the next part, part 3, later.